Hello, my name's Andrew Williams and I'm an area manager here at Skalar Analytical in the Netherlands. Today is part 2 of an ongoing series of videos where I'm gathering up the 5 most frequently asked questions across all our different product groups. And today I will be talking about the BOD application, Biochemical Oxygen Demand. This application on our SP2000 series of robotic analyzers. So as we're providing an automation method, I think it's good just to go over a few of the basics of the BOD analysis. And those are basically that you take a known amount of sample, you dilute it with a known dilution factor using dilution water containing a certain level of nutrients. Often the dilution bottle will also contain a nitrification inhibitor, which I'll come to a bit later. We measure the dissolved oxygen concentration of the sample on day 1. The samples are then incubated for 5 days, and then a final dissolved oxygen measurement is made and the BOD is calculated accordingly. So, question 1, what are the automatable steps on the robotic platform? So keeping in mind that within the theme of automation there are of course different levels of automation, semi-automation all the way up to say total automation. So number 1, dilution water addition. So this is based on the idea that the operators have manually pipetted the samples into the dilution bottles themselves. So number 2, sample pipetting and transport. So this is instead of the operators manually placing or pipetting the samples into the dilution bottles, the robot would do this automatically based on a predetermined dilution factor, and then of course the necessary addition of dilution water, as I've just mentioned, would also be done automatically. So number 3, additions. So that can be the addition of a seed to ensure that every sample receives a certain amount of, let's say, microbial activity. Often the seed can also be placed in the dilution water itself. Another addition might include ATU, so that's a nitrification inhibitor, and that's a question of the method itself as to whether you want the oxygen demand coming from nitrification within the sample to be included in your final BOD result. This is selectable actually at the level of every sample, so samples requiring ATU, not requiring ATU, that can be programmed in the software itself. So then we have capping and decapping. So this 5-day incubation process has to take place in an airtight bottle, so we need to get the cap on the bottle as quickly as possible. This can also be done fully automatically as an option. And what this actually allows is, say, more of a walk away time, and of course allows laboratories to work outside of working hours, because like I say, you need to get the caps on those bottles as quickly as possible. That of course becomes especially interesting for your day 5 readings if they fall at weekends, for example, where there's low operator availability or the lab is closed for business those days. The instrument can come back, decap the bottles and perform that final reading. Then number 5, pH measurement and or correction. So according to the ISO, the original sample should have a pH of between 6 and 8. So it's important to measure that, to know that the sample is within a working pH range. Some people just want to record this and flag the sample if it's not. But what we can also do is go to that sample again using an integrated dispenser and add a certain amount of acid or base to bring the sample to within that working pH range. And lastly, aeration. So again, samples on the day 1 dissolved oxygen reading. The samples in the dilution bottle, the diluted sample, should have a dissolved oxygen concentration of 8 milligrams per litre or greater. If that's not the case, the system can be configured to automatically aerate, sparge the sample to get that necessary level of oxygen into the sample on day 1. So just to conclude and to be clear, any combination of the functionalities that I've just described can be configured on our platforms so as to provide an optimal solution for any laboratory, or to really position the robot correctly within the workflow of a laboratory. So question number 2, what is a typical sample throughput? So based on a single probe configuration, we specify about 80 to 90 bottles per hour, and by adding a second dissolved oxygen probe, this could actually move to 150 or 170 perhaps bottles per hour. So here I'm referring to the DO measurement only. Of course, the total throughput on day one would be extended depending on the number of automated steps we have included in that sample preparation stage. So if you have to pH correct the sample, that takes some time, depending on the buffering capacity of the sample, for instance. So there are some variables which makes it a little difficult to be completely precise at all times. Of course, on day 5, where you only have to do that final measurement, the numbers I've specified would be, very typically expected. Question number 3, what type of bottles can we supply? Can customers use their existing bottles, and can they use any of their existing hardware? So the BOD robot can be configured for capacities ranging from 18 all the way up to 198 dilution bottles. That's based on 300 ml bottles, and of course that number could increase if we were to implement smaller footprint bottles, which we have often done. But in principle, the analyzer can accommodate all standard BOD bottle types and a wide range of sample trays, which is useful for the different types and different sizes of incubator and incubator shelving. And lastly, just to mention that pretty much all current major brands of meter and probe can be configured with our hardware and our software, which would allow customers to potentially integrate the meter and probe they're using in their current manual procedures. So just a few examples here of the different bottles we have integrated, so a few different shapes and sizes, but what we're really looking at, so I mentioned footprint determining capacity. So if you see here, by going to a slightly smaller footprint bottle, so footprint in the tray, we would be able to go to a higher capacity per tray using these smaller bottles. Of course, the total volume is the main difference in the end. Factors for us to consider are just, of course, the neck size of the bottle, because you have to keep in mind that we have to be able to go into the bottle with the probe and a stirrer. Of course, some of the probes have the stirrer functionality integrated on them. And just to come back to the point about customers using their existing hardware, just to mention that pretty much all current models of oxygen meters and probes can be integrated with our hardware and our software. So question number 4, can the system itself choose the appropriate dilution factors for samples? So in principle, yes. So far we've talked about mainly the hardware side of things, but we have implemented a number of features in our software which allow us to not only automate the hands of the operator, but also the brains and the thinking process behind a BOD analysis. So for systems including the sample pipetting functionality, what you can actually do is assign a certain dilution factor to a certain type of sample. You can actually take these values straight from the ISO 5815 norm. So something like a river water or a more pristine, cleaner sample will of course receive a much lower dilution factor than, say, a municipal crude sewage, which would need to be diluted 100, 200, maybe even 300 times. Then we have a kind of smart dilution factor assignment functionality. So again, based on the ISO 5815, this norm actually also contains a table of R values. So what you actually do is take a COD result or a TOC result, or maybe a permanganate value result, apply a certain R value, which will give you the necessary or the appropriate BOD dilution factor. This data can be imported into the software, so if you already have your COD values, that can be imported from your LIMS, and then that calculation will be made fully automatically, so eliminating any potential transcription or operator errors. And then with time, what this also allows is you to build up a database, or say a sample history, a dilution history for a particular sample. So every time you receive that sample, because often laboratories are receiving the same samples on a regular basis as part of ongoing monitoring of that sample location. So as you build that up, every time the software sees that sample ID, it will receive that dilution factor. As it did last time. This can be manually overridden if a sample is particularly dirty compared to what it was last time. So there is always that kind of visual check, if necessary, from the operator's side. This can also be done from a manual barcode reader. So that information could be contained within the barcode of a sample as it's received at the laboratory. And ultimately what this means is basically, if you know the sample, if you know which dilution is going to give you a result that you can report, this avoids the need for multiple dilutions, so a bigger loading capacity on the robot. It also means that there are less dilution bottles, so less space is taken up in the incubator. So and then of course less reanalyses, less lost samples. So all good stuff from an operator point of view. And then I suppose lastly, it's worth saying that what it also means is with time, operators do not require that in-depth or say real detailed working knowledge of every sample that arrives at a laboratory, which is of course useful for larger contract labs, commercial labs, and so on. Which brings us lastly to question 5. Will the system highlight any potential errors in the analysis, and will it select the best results for reporting? So yes, in principle, the most common practice is that traditionally on the manual method, you would report the result with the lowest, which used the lowest dilution factor, which just means that any potential error from within that manual procedure is multiplied by a smaller number. Also, what you see at some customers, if there have been multiple dilutions on a single sample, what we can do is take all 3 results and take an average, calculate the mean BOD result based on all the dilutions performed on a sample. So for error detection in your results, a good example would be the toxicity effect that is observed in some samples. So what that comes from is actually some samples just in their nature. So samples coming from industrial wastewater facilities, for example, can contain certain chemicals which are antimicrobial in nature. And actually what you do is kill off the microbes, the bugs in the sample, which means that you will actually see less oxygen being consumed. So you will actually have higher BOD results as the sample becomes more dilute, which is of course the opposite of what you would expect to observe. So on day 5, because of course you would only notice this on day 5, if the software detects this happening in a series of dilutions, the software will automatically highlight this to the operator. So that concludes today's video on the BOD application on our SP2000 series of robotic analyzers. I hope you found that information useful. If you require any more information, do not hesitate to visit our website at www.skalar.com. Thank you very much.